So this is day 8 of solving math problems until a whole life member notices me. So we have a differential equation here with initial conditions. So we're pretty much told to solve this differential equation, and we could see that it is a second order differential equation. So here what I'm going to do is simply go ahead and use Laplace transformations to solve for y of t. So our goal pretty much here is to solve for y of t. So we're going to start off by taking the Laplace transform of everything. So I will have the Laplace of y double prime minus 6 Laplace of y prime plus 15 Laplace of y and 2 Laplace of sine of 3t. So here we are not going to do all the integration. So I'm just going to go ahead and just write out pretty much the expression of Laplace of y prime, y double prime, y, and sine of 3t. So pretty much here we're going to go ahead and start off with having s squared and s squared and capital Y, and we're going to have t. S. And we're going to have minus sy of 0 and minus y prime of 0 and minus 6 times sy of s minus y of 0 plus 15 y of s. And that is going to be equal to 6 divided by s squared plus 9. And we're going to just plug in what we know because we know that we have y0 and y prime of 0. So I'm going to first factor out a y of s for everything. So I'm going to have y of s times s squared minus 6s plus 15. And it is going to be, so we're going to have y prime of 0, which is going to be plus 4, and minus or plus 6 times that, which is going to be minus 6. So pretty much we're going to have negative 2, negative 2, and then the s, which will be plus s, and that is equal to 6 over s squared plus 9. And we're going to subtract s and add 2. So y of s is equal to, and we're also going to divide at the same time the quadratic in terms of s. So we will have 6 divided by s squared plus 9 times s squared minus 6s plus 15. And then plus s or plus 2 minus s all over s squared minus 6s plus 15. So if we combine the entire fractions by just multiplying by s squared minus 9. We're going to get that it's a cubic, so we're going to have negative s cubed and 18 and then 9s. So we'll have plus 2s squared and minus 9s. And 18 plus 6, that is 24. And that is pretty much divided by s squared plus 9 over s squared minus 6s plus 15. And pretty much we're going to now go ahead and do some partial fraction decomposition, pretty much splitting it into two different fractions and separating the multiplication in the denominator. So we have y of s is negative s cubed plus 2s squared minus 9s plus 24 all over s squared plus 9 times s squared minus 6s plus 15. So now pretty much what I'm going to do is split this up so we have negative s cubed plus 2s squared minus 9s plus 24 all over s squared plus 9 times s squared minus 6s plus 15 is equal to as plus b over s squared plus 9 and plus cs plus d over s squared minus 6s plus 15. And we're pretty much going to multiply, or pretty much we're going to set the numerators equal to each other. So here we're going to have negative s cubed plus 2s squared minus 9s plus 24 is equal to as plus b times s squared minus 6s plus 15 and plus cs plus d times s squared plus 9. Yeah, this is a lot of work. And we're going to expand all this, and we're going to have, let's see, a cubed. Okay, so we're going to have a plus c s cubed, and the squares, let's see, so we have negative 6. Okay, so we have plus negative 6a plus b and plus d s squared plus 15a plus 9c and minus 6b times s. And finally I will have plus 15b plus 9d.
My name is Car. Fire hazard guru.
So so now what we can do is pretty much set the values equal to each other. So here we have a system of equations where we're going to have a plus c is equal to negative 1 and negative 6a plus b plus d is equal to positive 2 and 15a minus 6b plus 9c is equal to negative 9. And we're going to have 24 is equal to 15b plus 9d. So like solving for a in the first equation, we're going to have a is equal to negative 1 minus c. Plugging in a into the second equation, we will have 6 times 1 plus c, which will be 6 plus 6c plus b plus d equals 2. And we're going to solve for b. And b is going to be equal to negative 6 c and then minus 4 minus d. And plugging in a and b into the third equation, we're going to have 15 or minus 15 minus 15c minus or plus 36c plus 24 plus 6d plus 9c equals to negative 9. And here we're going to have this right here becomes and in the third equation, we're going to have 15 minus 15c plus 36c plus 24 plus 6d and plus 9c is equal to negative 9. And this is negative, and pretty much adding negative 15 and 24, that gives positive 9, which we're going to simplify everything else. We have 30c plus 6d plus 9 is equal to negative 9. So we see there's a bunch of crazy and scary algebra, but it's fine. And we're going to subtract 9 from both sides, which gives negative 18. And then solving for c, we'll get that pretty much c is equal to negative d minus 3 over 5. And we just plug everything into the final equation, and we should get a value for d. And then that solves c, and then goes to b, and then a. So we're going to finally have the whole equation, which is going to be 15 times negative 6 times negative d minus 3 over 5 minus 4 minus d plus 9d, which is equal to 24. And expanding everything, we will have that the inside will simply be 15 times 6d plus 18 over 5 minus 4 minus d plus 9d, and that is equal to 24. And the inside will pretty much just become Or on the left side, after a bunch of manipulation, it will just be 12d minus 6 is equal to 24. Because if we just pretty much make this into a 3 and multiply everything else by 5, the denominator disappears, just leaving 6d plus 18 and then 20 and 5, which pretty much here it would be this and this almost cancel out, which would just pretty much give us minus 2, and the d's will pretty much become just d. So pretty much we would have d minus 2 plus 90 equals 24, which simplifying gives 12d minus 6 equals 24. And solving for d, we have 12d equals 30, and d is equal to 30 over 12, which becomes 5 over 2. So we found d, which is very nice. And we're going to just plug everything into A, B, C, and get the values. So we're going to have C is equal to negative 5 over 2 minus 6 over 2, and that is going to give us minus 11 over 2, and that is all over 5, which is going to be 11 over 10. So we found C is equal to negative 11 over 10. And B will be equal to 66 over 10 minus 4 minus 5 over 2. Multiplying by 5, we have 25 over 10, and this will be 40 over 10. Just adding everything that's in the numerators, we would have 66 minus 65, which is going to be 1 over 10. So B equals 1 over 10. And here we're going to have A, which is negative 1 minus 11 over 10, which would give A is equal to 1 over 10. So A equals 1 over 10.
Let's go!
So solving that system of equations was pretty long, but it could have been worse. So pretty much now all we have to do is go ahead and plug in our values for A, B, and CD. So we have 1 over 10 and 1 over 10, and C and D we have negative 11 over 10 and 5 over 2, or namely 25 over 10. Or we can factor out a 1 over 10, which gives y of s is equal to 1 over 10, and then pretty much everything else. S plus 1 over s squared plus 9 plus negative s, or actually, hold on, minus 11s minus 25 over s squared plus 6s plus 15. Actually, it's minus 6s. So now what we're going to go ahead and do is see what we can do with these expressions. So we're going to go ahead and take the Laplace inverse of s over s squared plus 9, which is going to give us cosine of 3t. Okay. And the Laplace inverse of 1 over s squared plus 9. That is simply just 1/3 sine of 3t. And this right here, we're going to manipulate the one with the quadratic denominator. So we have y of t is equal to 1 over 10 times cosine of 3t and plus 1/3 sine of 3t So the 11s minus 25, we're going to complete the square for the bottom first. So we will have, let's just erase the rest and leave it like this. So we're going to have 11s over s minus 3 squared. And then I don't know, we're going to subtract 9, so it's going to be plus 6. And then minus 25 over s minus 3 squared plus 6. So pretty much what we're going to go ahead and do here is manipulate the expression a little bit. So here we're going to just ignore the negative for now. So it will be 11 times s minus 3. And it will just be over s minus 3 squared plus 6. And it will be plus, I just ignore the negative and factor it out. This would pretty much give me 11 minus that, which was 8. And divide that by s minus 3 squared plus 6. And taking the Laplace inverse of pretty much all of this, I would end up with 11 e to the 3t because of the s minus 3. And I would have cosine of root 6t plus 8 over root 6 e to the 3t sine of root 6t. So since it's all negative, all the expressions will be negative. So finally y of t will be equal to 1 over 10 times cosine of 3t plus 1/3 sine of 3t minus 11 e 3t cosine of root 6t plus 8, or actually minus 8 over root 6 e 3t sine of root 6t. So pretty much this would be our entire solution to our differential equation, which was very tedious but also very fun to do. And yeah, this pretty much is the kind of stuff that would probably make anyone go insane, but not me, because of course this is fun. I'm only saying that just to see the reaction of Gura or Crony. I feel like they're probably like, what? You think math is fun? Wow. Or something along those lines.
I need answers.
But yeah, this is pretty much the whole solution to this differential equation right here. So yeah, just take a bit to bask in this monstrosity of a solution.
What?
Well, it's not even that bad. I've seen worse.
What?
So yeah, thank you for watching, and hopefully you actually like this. Probably just watching me suffer, but demo arigatou gozaimasu, and yeah, bye bye.